Hi everyone. Good morning guys. Very good morning all of you. Shruti, Tajamul, Diya, Anjali, Praneeth. Good morning everyone. Karthik. Very good morning all of you. How are you all? Everyone, how are you? How are you all guys? Hello. Fine or not fine? Supriya, good morning. Fine? Okay, very good. All of you had your tea, coffee, hot water, juice, breakfast, everything or nothing? Yes, I am good as usual. Tea, coffee, hot water, juice, breakfast over or not over? No, not over. Okay, don't worry, we'll be having a good breakfast of questions, right? So this engineering mechanics. So it is an engineering mechanics concept through questions and part 2 SSC JE and state JE. Okay, right here. All of you, welcome to Unacademy. Let's crack it, right? Everybody is ready to crack, all of you, or not ready to crack? Everyone is ready to crack. Everyone get ready to crack, right? So now this is my profile. You can follow me at which, and what is that referral code you have to use always? RP Civil is a code you have to use, and you recommend the same code to your friends also, right? Now, so these are all SSC JE and State AE 2022 toppers. If you want your name to be displayed here next time, you work hard, you work smart, and attend classes regularly. Don't miss the classes, right? And practice PVQs and practice test series, right? Okay, Ashwin, good morning. Now, so here this is a Samarth batch, right? This recently what is it started, right? Samarth batch for this SSC JE State AE JE examinations is started now, everyone. So it is started on which one? This August 15th, all of you, right? From August 15th it was running. This batch is going on, and what is it code? RP Civil. If you are joining this, so this is a fee structure you are having 24 months, 12 months, and this is 6 months fee structure. The RP Civil is a code you have to use, right? Yeah, good morning Ashwin. Now so what happened? KP sir has started environmental engineering, and Amit sir has started already RCC na. So no, these two subjects are running now, and my surveying is also running, right? So these three subjects are running now. 25th onwards will be starting which one? This reasoning, right? 25th onwards will be starting that reasoning subject, you can say, everyone. Okay, right. Now, so these are the details of your batch, you can say. If you just observe, these are the faculty teaching. So have you all completed this application for this SSC JE, everyone? Have you all completed the application of this SSC JE? Yesterday it was the last date, na? Yes or no? So you should not, none of you might have missed it, seems, right? Yes, na? Okay, very good then, right? So AAI also, that AAI JE also, right? Junior executive, it is also there up to September 4th, right? So those who are applying for this, you don't miss this, right? You try to apply, everyone, right? If you are willing to apply, right? You just apply, right? Only you will be losing is that exam fees only, na? But you will be getting that experience, right? Yes, na? But you will be getting that experience of examination and questions, how they can be covering, right? Like that. And the non-technical part, anyway you are preparing for SSC JE and your state examinations, na? So there is no separate preparation required now, right? This is concept through questions. Which topic? Engineering mechanics we are discussing, na? That is your engineering mechanics. It will be going on, okay? Right. So this is engineering mechanics, first chapter only. Forces, force systems, and work and energy, right? So what I am thinking to do is actually from every chapter, okay, 50 questions we'll try to do. That is that okay, everyone? Or 30 questions we'll do from this, so that we can cover more. 30 is okay, or 50? 50, okay, right then. So that you will not be getting anything beyond that, right? Even directly you may get the questions, or similar models also you may be getting, right? So, or all questions I'll try to do, which are possible. Repeated, I'll be taking it as repeated. Repeated questions I'll not take. Non-repeated questions. 70 seconds, 60 seconds more time. Yeah, no break. There will not be any break except Saturday, Sunday. Every week, Saturday, Sunday, classes will not be there. I told you already. Monday to Friday only will be having. Oh, it will be continued, don't worry. So Jamal answered correctly. Seconds more time. If anybody wants more time, you just ask me to increase the time, all of you. 10 seconds only. Right, over. Now, what is it you can say? A force of magnitude 5 Newton moves through a distance of 4 millimeter in a direction inclined at 60 degree with the direction of this force, right? The magnitude of this work done by the force is, right? So what is the magnitude of this work done by the force? If you just observe simply what is that work done, you can say work is nothing but your force into distance, everyone. What is that work, what is that force you, what is that work, you can say everyone. Work is nothing but your force into distance, or not all of you? Yes, force into distance. But which force we have to consider? That entire 5 Newton force we have to consider, or we should consider only the component of this force we have to consider, everyone? Entire 5 Newton force we have to consider, or only the component of this force we have to consider, everyone? Only that component of this force we have to consider. Now, why? Force magnitude of 5 Newton moves through a distance of 4 millimeter in a direction inclined at 60 degree to the direction of this force, right? So what is it you can say? It is moving in which direction? In the same direction of this force? No, no. Suppose if the force is applied like this, this is your force applied. So but what happens in this direction? It is moving, na? Yes or no? In this direction, what is the displacement occurred? If you just observe, this is your theta, you can say, right? This is your f cos theta, right? F cos theta will be creating which one? This motion, right? So from this point to which one? This point motion is created, if you just observe. But even though force is applied like this, but motion is created in this manner, right? Yes, no? Right? So here what is this displacement, or this what is the distance it is moved? 4 millimeter is the distance moved, now 4 millimeter is the distance moved, right? Therefore what is that work, you can say everyone? Work is equal to that f we have to consider, or f cos theta we have to consider. F cos theta into that delta, na? What is it? F 5 newtons. 5 newtons into what is that angle given? 60 degrees, na? So that is your cos 60 into what is that? 4 millimeter, right? Tell me how many Newton millimeter is the work done, everyone? How many Newton millimeter is the work done, all of you? How many Newton millimeter? It is 10 Newton millimeter, everyone. 10 Newton millimeter. Right. So is there any option with that? 10 Newton millimeter at option C will be the correct answer, na? Option C will be the correct answer. You can say if you just have read. Is it clear, everyone? Right? Right? So now shall we move to the next question, all of you? Shall we move to the next question? Right. So this is 12th question. So 12th question, I will be starting the poll. Try to select the answer of you. 45 seconds time I am giving. Okay, you want me to wait? Okay, note it and tell me. Clear? This is clear, everyone? So force is equal to which one? Work is equal to force done, force into that, force applied into that displacement caused by it, right? That is your work done, you can say. Because it is creating displacement in a direction 60 degrees to the force, then we have to consider work in that direction only, or force component also in that direction only. We cannot go with the total force. Yes, now? Why we have used the component of force only? Is it clear, everyone, now? Why we have used the component of force only? Is it clear? Right? Now, this one, select the answer of you. This is West Bengal PSC question. Like that, when you are covering all state PSC questions, now automatically what happens? You can say automatically what happens, right? You can be able to cover all now. All models can be covered easily now. Diya Tajamul answered correctly. Yeah, what is it you can say? A point is subjected to which one? A point is subjected to number of forces will be in equilibrium. When it is in equilibrium, if we just observe, sum of the forces in the x direction is 0, sum of the forces in the y direction is 0, right? Or you can also write it as sigma h na, sum of the horizontal forces and sum of the vertical forces 0, right? Sum of these resolved parts in any two directions at right angles are both 0. That is correct or not? Yes. Algebraic sum of forces is 0. Is it simply the algebraic sum of forces 0, or algebraic sum of forces in two perpendicular directions are 0? Tell me. Algebraic sum of forces is only 0, or algebraic sum of forces in the x and y directions are 0? Which one is correct? Algebraic sum of forces in the x and y directions should be 0, na? Algebraic sum of forces in the x and y directions should be 0, right? Is it clear, everyone? Suppose if you are having it like this, one force is in this direction, one force is in this direction at q, right? Can we say just p plus q equal to 0? Is it correct to say p plus q equal to 0? No, no. P plus q can never be 0, right? P plus q should not be 0, right? What is that you can say? The components, right? Component of p in the horizontal as well as in the vertical direction. And what is it you can say? Component of this q also in the horizontal as well as in the vertical direction, right? What is it you can say? Now if you consider these two components, these two components will be equal to 0, right? Sum of the forces in the horizontal direction, sum of the forces in the vertical direction will be 0, right? Like that. Is that clear? So two resolved parts of any two directions at right angles are equal. Are they equal? They need not be equal, is not? Algebraic sum of these moments of these forces about this point is 0, right? Is not? This is also correct, na? So which options are correct, na? Option A is correct, but can we say option D is correct here? Can we say option D is correct here, or option D cannot be correct, everyone? TP, good morning. Option D can be correct, or option D cannot be correct? Option D cannot be correct, right? Why? When all forces, right, at a particular point, right, at a particular point, all forces are acting. Now tell me, will there be any moment created by these forces about this? No need to consider that equilibrium separately, na? Moment equilibrium need not be considered separately or not? Moment equilibrium need not be considered separately, right? But why? All loads are passing through the same point. So moment equilibrium is required to be considered, or no need to be considered? No need to be considered. What is the question given? Here, a point is subjected to number of forces, right? This is the point given. This is your P force. This is your Q force, right? This is your F force, right? This is your which one? This R force. Now tell me, sum of the moments about this point equal to 0. Do you need to consider or no need to consider? No need to consider, no? Why? Because all forces are passing through this point only. When all forces are passing through that point only, will they be able to create any movement about that point, or no movement they will be creating about that point? No movement will be created about that point, na? When no movement is created about that point, moment equilibrium. First of all, moments will come into picture, or moments will not come into picture? Moments will not come into picture, na? When moments will not come into picture, right, you need not go for which, right? You need not go for this moments, na? Moment equilibrium, na? Only force equilibrium is sufficient enough or not? Yes. Suppose if it is a member given, forces are acting at a different locations, then moment equilibrium is required. Yes, now moment equilibrium is required, because these forces will cause which one? These forces will cause which one? This moment, na? because these forces will create moment about this point here na? But here any force will create a moment about this point O, or no force is creating moment about this point O? Tell me. Any force can create a moment about that point, or no force will be creating moment about that point? No force will be creating moment about that point. Yes, because all points are passing through that. If you try to write the moment, force into distance. So load is acting at O, moment is also required at O. What is the D? D distance will be 0. So moment created by force P, force Q, force or any force, it will be 0 only, right? There is no question of moment, right? Now tell me, moment equilibrium sigma m equal to 0 condition will be applicable or will not be applicable here? Sigma m equal to 0 condition will be applicable or will not be applicable, all of you? They are not at all create. Even if you apply, what you will write? Even if you apply that, right? Even if you apply that, right? Is there anything to calculate? Nothing to apply, na? Nothing to calculate, na? Yes or no? Nothing to calculate, na? Because when you have to apply that, tell me. When you have to apply that, tell me. When you have to apply that, tell me. When moments are present, you can say that algebraic sum of moments will be equal to 0. When moments itself are not present, which moments you consider? Tell me. When moments itself are not present, which moments you consider? You don't have any moments created by any force. Therefore, no moments will be considered, right? Like that. Is that clear now? This one, everyone, all of you. Everyone, it is clear? Why we are not considering algebraic sum of these moments? Because every moment is 0. P into 0, Q into 0, R into 0, F into 0. Every force is creating 0 moment. Then where is the question of algebraic summation comes? So no need to, do you need to apply the, do you need to check that moment equilibrium or no need to check that moment equilibrium? Do you need to check the moment equilibrium separately or no need to check the moment equilibrium separately? No need to check the moment equilibrium separately, na? Force equilibrium, if you check, it is sufficient enough. That is why option A only can be the answer, right? Like that. Is that clear? Shall I move to the next question of you? Right. Select the answer. This is Uttar Pradesh question. Ashwin Diya Tajamal answered correctly. Anjali also answered correctly. 80% only answered. Remaining 20% cute fellows. Right. Consider the following statements. Question number 13. According to principle of transmissibility, force can be applied at a point on an object in its line of action which creates the same moment about the considered point, right? Is it so? According to the principle of this transmissibility, force can be applied at any point on the object in its line of action which creates the same moment about the considered point, right? So what does it mean? Let us say this is the point about which I require moment, right? Moment about this O. Now if I am applying, right, if I am applying the load at this place, right, if I am applying the load at this place, so it will create how much moment? Tell me. This perpendicular distance we have to consider now. Let us say this is your D. So what is it? You can get it P into that D. Now along this line of action, if you are applying that load at this place, do you have any problem? If you are applying, sorry, if you are applying the same load at this place in the same line of action only, it is the line of action, na? So here I am applying, here I am applying. This also will create the same moment about this O or not? This also will create the same moment about this O. Now tell me, do you have any problem in shifting that load from that place to this place, everyone? Do you have any problem in shifting the load from that place to this place in the same direction, right? In the same direction, in the same direction as well as in which one, right? In the same direction as well as which one? At the same distance. Then it will create a same moment, right? Now is that okay, everyone? That is correct only or not? That is correct only. That is only principle of transmissibility, right? What is it you can say? we can shift the load from one place to other place, but that shifting must be along the line of action of this force only, right? And it should create a same moment about a particular point considered as that of previous. Is that clear everyone, that first one, first statement? Is that clear everyone, this principle of this transmissibility, all of you? Principle of this transmissibility, is that clear? That is only principle of transmissibility, right? That is why if you just observe na, whenever you are having in your structural analysis or somewhere you might have observed, suppose if this is the load P acting na, then how can you simplify that if there is no other external load? We can just remove this and we can apply this load as it is na. We can shift this load from this D point to this C point na. D point to this C point, you can shift it na. Have you done this kind of questions or not? Load can be shifted from this D point to this C point. Why? Because we can shift it if it is acting along the line of action original line of action only. If it is replaced, no problem, right? Have you done this kind of things or not everyone in your structural analysis? Hello? Nobody is there in the class? Have you done or not these kind of things? In strength of materials also have you done or not? Or strength of materials are this one, whenever this kind of one is there, no? This is that load you are having, let us say, suppose if this is a load P acting at a distance of A. This kind of questions are even in university examinations point of view are also important. Then what you can do, you can shift this load, you can shift this load like this P, and what is it, you can apply this moment P into that A like that. Have you done this? So what is the difference between this one and that one? What is the difference between this one and that one, right? Structural analysis. So whenever you are having a member in this manner, whenever you are having it, so that force P is applied in this direction, let us say. So this is your A, this is your B, this is your C, this is your D. Now tell me about this C point, what is the force P creating? Zero moment na. About this B point and A point, what is the moment it is creating? So moment about this BA line, what is that? It will be equal to that P into that L na. P into that L or not clockwise. Now what is the moment about this point C, you can say that is 0, right? Now if you are shifting it, right, if you are shifting it like this, right, what happens, right? You can shift this load P in this manner, you can shift this load P in this manner. Now tell me, is there any change in the conditions of this moment if you just observe? Because it is passing through the point C, that moment at C will become 0, and moment about this AB line will be how much? That same P into L, right? Now if you are shifting it like this, is there any change in the moments about these points, or there are no change in the moments about those points, you can say? There are no changes in the moments about those points. No? Now do you have any problem in shifting the load like this? Yes, we don't have any problem in shifting the load like this. So that is called as your principle of transmissibility, right? So we can transport, or we can move the load from one place to other place. But how to move? We can move only along the line of its line of action, right? Now it is the line of action. This vertical is the line of action of this force. We have shifted it in the line of action down upward direction only. No, either you can move it in the upward direction of line of sight, or downward direction of line of sight, or left side or right side of this line of action. Okay. We have shifted it in the line of action only, no? We have shifted it in the line of action only, no? Line of action direction only, no? It is acting on the line of action only, and it is creating same moments as that of original. Then we can shift it like this. This principle is only called as transmissibility, principle of transmissibility. Now it is clear, all of you? What is the principle of transmissibility? Everyone? Clear, no? So how it will be useful, tell me? We can shift the load from one place to other place along its line of action only. We have to shift it, right? And it should create same moments as that of original, right, at a particular point. So what is the purpose of this one? If you are doing like this, it will simplify the question solving, na? It will simplify the question solving, definitely, or not everyone? Yes, it will simplify the question solving if you just observe, right, like that. First statement is correct. So second statement, if you just observe, according to the Varignon's theorem, moment of resultant forces of a system of force acting on a body about a point is inversely proportional to the moment of all the forces acting on the same object about the same point. Anyone tell me what is that Varignon's theorem? Anybody remembered first of all? Anybody remembered Varignon's theorem? What is the Varignon's theorem? Anybody? So here, okay, I'll be right. Shall I write the definition of this Varignon's theorem? This is a principle of transmissibility. You can note it, right? You can note this as it is. That is correct only. Yeah, you can note it as it is, right? Here, what is that you can say? So first I'll explain just with a figure. Then, okay, Varignon's theorem. So what is the Varignon's theorem? Just suppose you are having, let us say these are the forces acting, right? At this point P, at this point A, let us say this is a force P acting, this is a force Q acting, this is your which one? This is a force R acting, and this is your force F acting, right? And tell me, these forces will be creating some moment about this B, na? So these forces can create some moment about this B, or not everyone? These forces can create some moment about this B, na? Is that no? So the now what happens, these forces, concurrent forces, will be creating some moment about a point B. Now what is that you can see is, we will be replacing all the forces with the resultant force only, right? Let us say this is the resultant force, right? This is which one? This is the resultant force, F resultant. Now the resultant force will be creating that same moment about this B as that of original. That is a Varignon's theorem. Now it is clear, everyone? Varignon's theorem meaning is clear. The meaning of Varignon's theorem is clear, all of you, or not clear? Hello? Right? What is that Varignon's theorem? In many coplanar forces acting on a body, right? It may be coplanar, it is collinear also, right? Coplanar forces. So okay, if you consider like this also, right? Coplanar forces means all the forces are acting in the same direction, same plane. You can say this is your P, this is your Q, let us say this is your F. So about this is some point B, they will be creating moments. So algebraic sum of all the moments created by these three. Okay, we'll be having algebraic sum of all the moments created by these three. Now that will be equal to which one? That will be equal to which one? The moment created by this, the moment created by their resultant force, right? The moment created by their resultant force about the same point is the same. Got it now? So algebraic sum of individual moments created by forces about a point is equal to the moment created by their resultant about the same point. Has now got it? Got it now? Okay, we just shall I write the definition? What is the Varignon's theorem? In coplanar forces, right? What is the meaning of this coplanar forces? In coplanar forces, right? What is the meaning of this coplanar forces? All forces are present in the same plane, na? All forces are present where? All forces are present in the same plane only, right? That is in coplanar forces system on an element. So what happens? You can say algebraic sum of which one? Moments due to all these forces about all these forces about a point will be equal to which one? Will be equal to which one? Moment by their resultant force, right? All forces we are replacing with which one? This is single force now. Moment by their resultant force at that point. About that point, sorry, not it, about. Now is that clear everyone? What is the Varigna's theorem? So it is telling that you can replace all these individual forces with a single resultant force that will create the same moment as that of original, na? Yes or no? Is it clear? Clear everyone? Once clear, note down. Once noted, tell me all of you. This previous one you are noting? This previous diagram you are noted? So this is sum of the moments about this B point will be equal to which one? This moment about this B point because of this resultant, right? Yes, no? Right. Done everyone? Right. So now tell me second statement is correct or not? Is it telling the Varigna's theorem or not? According to Varigna's theorem, moment of resultant force of a system of force acting on a body about a point is inversely proportional to the moment of all the forces acting. It is inversely proportional or it is equal, we have to mention. It is inversely proportional or it is equal, we have to give. It is equal should be given, yes or no? When it is equal is given, then it will be correct, right? Inversely proportional to is wrong. Yes, that is the wrong, you can say, right? Clear? So statement B is wrong, na? Which one is correct? Right? Option D will be the correct answer, right? Like that. Shall I move to the next question, all of you? 14th question. Shall I? So principle of transmissibility and this Varignan's theorem both are correct or not? Yeah, A is true. A is true. I have mentioned A is true. No, you know, say statement A is true, B is false. Principle of transmissibility, what it tells, you can relocate or you can move, you can dislocate the force from one place to other place, but along which one you can relocate? Along its line of action only we can relocate, such that it will not change the moment created about any point, okay, even after replacement also. Got it? So first statement is correct only, principle of transmissibility. Second one is wrong. Sort of. Good morning. 14th question, shall I go for? Select the answer of you. Gopi, good morning. Tajamul and Dia only answered correctly. What about the remaining? right? Okay, so here two forces are acting at a point B, right? Two forces are acting at a point B and C in the system of cable shown in the figure. Calculate the tension force developed in the cable CD. Here you are asked to identify tension force developed in this cable CD to keep the system in equilibrium, right? Tension force developed in this CD only you are asked to identify now. How can you calculate this CD if you consider this equilibrium free body diagram, right? Now you consider which one, this is a free body diagram of which point you can say? Free body diagram of this which one? Everyone, free body diagram of which point? That is C point you have to consider now, point C. Free body diagram of this point C, right? What is the free body diagram of this point C? You can say here the force 800 newtons is acting like this downward direction. This 800 newtons is acting in this downward direction. And what you can consider? You can consider this as which one? This is a tension in this CD now. Can we say instead of this cable we can consider tension in this CD now, and this one tension in this CB we consider now. Instead of this CB wire we'll consider this tension in this CB, right? Tension in this CB, right? Or BC, whatever it is. This is the point C, right? Now how can you calculate this tension in this CD? First we should know these angles now. What are these angles? We should know. That is 60 means, okay, this is 30 means, right? What is that? You can say this is also 30 now. That is 60 means, right? What is this one? This is also 60 now, is it no? And what is this one? This is 30 means, right? What is this one? This is 90 now. So now tell me, right, what is the angle between these two, right? And this is 90 now again. So what is this angle? 90 plus between this TBC and this TCD. What is that? 90 plus 60. How much it comes to be? 90 plus 60. What is that? What is it? $60 only? One sec. Okay, this is only 60. Oh, sorry, it is with respect to horizontal, na? Sorry, I have written wrongly. Yeah, this is with respect to horizontal means, right? What is this you consider? This is 60 only, no? Here, correct. Yeah, I have made angles wrong. Yes, correct. Yeah, okay. Don't worry. So this will be 30, na? Okay, this you can take it as 30, right? This is 30, right? This you don't have any doubt, right? This is a 30 only, no? This is a 30, right? And this is which one? 120. This is a 90. Okay. So this is 90 plus 30, right? Between this TCB and this 800, this is 120 degrees now. So here to here, right? What is the you can say? This is 120 degrees, right? This is correct only now. 120 degrees. This is right. Now, what is that? Here if we just observe, this is a 30. Whenever this is a 30, right? What is this will become? This will become, this is a 60 na, this will become 60 na. Yes, this will become 60, right? Here this is a 60 means this is a 60 na. Now what is this remaining, right? This will become this 30 na. Yes or no? This will become this 30, right? So what is this angle between these two cables? 90 degrees is the angle between the two cables now. Angle between the two cables is 90 degrees or not, everyone? Angle between the two cables is 90 degrees, right? Is that clear now? And what is the angle between this TCD and this 800 newtons? So that is 360 minus which one? 360 minus this, right? What is that you can say? 360 minus 120 minus 90, right? What is this value, everyone? This one. How much you are getting? 360 minus this, 120 minus this, 90, right? 150. 150. Okay. Now apply Lami's theorem. Yeah, you can also go it as which one? This 90 plus 60, right? This is 60, and what is this one? This is a 90. Yes. So 90 plus 60 also you can go it as 150, right? As you wish, right? You can go it in any manner, right? 90 plus 60. Like that, you can write it in any manner, right? Lami's theorem, if you just apply it, what is it you can say? That is your TCB divided by which one? TCB divided by this is sine 150. Do you remember that? Lami's theorem. So force divided by this opposite angle, is na? So this is which one? 800 divided by which one? 800 divided by this is sine, how much you can say? Sine 90 na? Equal to that TCD divided by TCD divided by this is sine 120. Now tell me, you are asked to calculate this tension in this which cable, CD cable or CB cable? CD cable only, no? You just consider these two. What is the TCD? You can get it now, 800 into sine 120 divided by which one? This is sine 90. Now how many newtons, that is Newton or kilonewton? How many newtons is the tension in that CD? Tell me. How many Newton is the tension in that CD, everyone? Six 692.82 newtons, right? Is there any option with that? 692.82 692.82, right? Option D will be the correct answer, right? Like that, right? Shall we move to the next question? Clear, everyone? Shall we move to the next question? Right, 15th question will go on to select the answer of you. Solve this. Okay. Okay, one sec, I'll wait. After this poll I have started already. After this poll is over, I'll wait there. Don't worry. Don't worry. 10 seconds more time. Same Lami's theorem only we have to apply now. Lami's theorem only we have to apply, right, everyone? Okay, Lami's theorem only we have to apply, right? You need not apply anything else, right? The three forces P, Q and R keep a body in equilibrium. The angle between this P and Q is 90 degree and R is acting vertically downward, right? Where is that R acting? You can say that R is acting vertically downward, right? This is the R force, right? So P and Q forces are acting like this, you can say. This is your P, this is your Q, and what is this angle, right? This is your 90 degrees now. And now this left side and this right side angles both must be same or not? These two angles must be same or different? These two angles must be same now. This is theta, this is theta, because it is symmetrical. Right? What is this value? Tell me. 2 theta plus this 90 will be equal to the total 360. Then what is that theta comes to be? 360 minus this 90 divided by this 2, right? What it comes to be? That is your 135 degrees now. 270 by this 2, 135, right? So this theta values are which one? This 135, 135. Now tell me, apply this Lami's theorem. Whenever you are applying this Lami's theorem, what happens? How can you get the answer? So this is R. What is that R value given? Is there any R value given? R is acting vertically downward. Then the magnitude of this force R and Q respectively in terms of P, right? In terms of P, you are asked to calculate now. Okay, let it be. r divided by this opposite angle, r divided by this sine 90 na, r divided by this sine 90 equal to what is it, q divided by which one, this opposite angle sine 135, sine 135 equal to p divided by which one, that is your p divided by this sine 135. Now tell me what is that r comes to be. R is equal to which one, this is p into sine 90 by this sine 135. Then what is that, q will be equal to, q will be equal to that sine 135 divided by this sine 135 into p, you can say, right? So therefore q will be equal to p na, q will be equal to p, right? What is that r will be equal to, tell me. R will be equal to how much? It comes to be this root 2p na. So because sine 135 is nothing but your sine 45, sine 45 is 1 by root 2, that root 2 will go to numerator, sine 90 is 1, so root 2p, right? So which one is the correct answer now, if you just observe, which one is the correct answer? The values of r and q respectively, r is first means root 2p, right? D option will be the correct answer now, option D will be the correct answer, you can say, right, like that. Shall I move to the next, shall I close the session now? Right, so I'll be closing the session now. Thank you all of you, have a good day. Right, tomorrow we'll discuss other questions, right? So you practice these questions again, so that what will happen, similar kind of questions you can answer easily, yes na, right? Thank you all of you, have a good day.